Good morning or good afternoon, and welcome to lesson 4 of module 1. Today we're going to be learning about the zeroth power and practicing the rules that we've learned this week about exponents. So let's go ahead and jump right into it on the next slide. All right, to just go over some things we have already learned, we're going to review. It says rules we have learned so far. When multiplying numbers written in exponential notation that have the same base, we blank the exponents. So for example, please write this example down. We have 5 as our base, and let's say the exponent is 2. And if we were to multiply this by another number that has a base of 5 and is written in exponential notation, maybe 10th power, what are we going to do to simplify this? What are we going to do with these exponents? Well, we are going to add them. Okay, so this becomes 5 to the 12th power. All right, so that's the first rule we learned. The next rule we learned has to do with division. So when dividing numbers written in exponential notation that have the same base, we blank the exponents. So for example, maybe we have 8 to the 8th power, and we're dividing this by a number that has the same base, so it has to have that 8, and let's say it's to the 5th power. This would simplify to be 8 to the 3rd power, and the reason why is that when we divide numbers that have the same base and they're written in exponential notation, all we have to do is subtract the exponents. And then lastly, the last rule that we have learned earlier this week, it says when we raise a number that is already written in exponential notation to another power, we blank the exponents. So here's another example. Say we have the number 6 to the 4th times x y to the 2nd. Okay, so this is our number written in exponential notation, and we're going to take this whole thing and raise it to the, let's do the 2nd power. How do we do this? Well, we learned it yesterday. What we would do is we would distribute this exponent and multiply it to each one. So 2 times this base. So we have 6, and 2 times that 4. That's going to be to the 8th. Next we have our x. It's going to be 2 times, well, there's nothing there, so it's just an invisible 1. 2 times 1, 2. And then it's going to go to this y. The y already has a 2, so we're doing 2 times 2. That would be a 4. So what we did is we multiply those exponents for each and every term that we have there. Please make sure you have all of this down. This is, again, what we have spent the week learning and practicing, and you're going to continue to use this information throughout this module, as well as throughout high school. Okay, this is really important stuff that you're going to use and build upon as the years go by. All right, let's move to the next slide. All right, here we're just going to go through some examples, and I want you to try them out, and then we'll go over them. So I'll give you about 30 seconds to work on this one right here. 4 to the 7th divided by 4 to the 5th. Please simplify that and write your answer in the chat. All right, so you should have remembered that when we divide exponents of the same base, we subtract those exponents. 7 take away 5 is 2. All right. Moving on to the next one, please do this one very quickly and then message me your answer in the chat. All right, so you should have remembered that when we multiply numbers that are already written in exponential notation by another exponent, we just distribute that, so it's going to be 3 times 2. It's going to be 6 to the 6th power. All right. Please do this one right here. All right, we are multiplying two numbers that have the same base. So we are just going to add those exponents together. 4 plus 3 is 7. All right, go ahead and do this next one on the bottom. 5 to the 4th times 5 to the negative 4th. One's a little bit trickier and kind of brings us to our new learning for today. So we are multiplying numbers that have the same base. So basically we're supposed to add the exponents, but this exponent is a negative, and we'll learn more about negative exponents next week. But 4 plus negative 4 is 0. I want you to put a star or a circle or, highlight this answer because we're going to talk about this later on. That's what this lesson is about. Okay? And then let's work on these next two together because they're pretty lengthy, okay? It says that x to the 41st first power divided by y to the 15th times y to the 15th divided by x to the 41st. So what they did is they just went ahead and combined these. They multiplied these up top, and then they multiplied these on the bottom. And now they have this full fraction right here, x to the 41st times y to the 15th over y to the 15th times x to the 41st. We could even simplify it further and remove those multiplication signs. So it could be x to the 41st, y to the 15th. This is just the same thing, right? We're just getting rid of the multiplication sign. And on the bottom, I'm going to do the same thing, but I'm actually going to switch the order. I'm going to put this one first because order does not matter when we multiply. So this is x to the 41st and then y to the 15th. Now, if we were dividing these, we would subtract. We have two different bases here. So we're going to work with each base at a time. So we have x to the 41st, and then we have y to the 15th on the top and bottom. And in order to simplify this, all I'm going to do is subtract. So x to the 41st minus x to the 41st, this is going to be x to the 0th power. And then y to the 15th minus y to the 15th, it's going to be y to the 0th power. And again, we are going to highlight this answer because we're going to talk about that 0th power later today. That's what this lesson is about. Looking at this next one, you'll see that pretty much the same thing is going to happen. We have 2 times 1 over 2 to the 5th times 2 to the 5th times 1 over 2 to the 2nd. All right? So essentially I'm just going to multiply these out and simplify it. So 2 to the 2nd times 1. This is just 2 to the 2nd. Okay? 2 to the 5th times 1 is just 2 to the 5th. And we kept our 2 to the 5th on the bottom and our 2 to the 2nd on the bottom, but we switched the order of them so that they were on top and on bottom of the numbers that look exactly like them. So again, I'll simplify this one more time by removing that multiplication sign. This is 2 to the 2nd times 2 to the 5th over 2 to the 2nd times 2 to the 5th. We could simplify it more because these numbers are being multiplied, so this is the same as saying 2 to the 7th over 2 to the 7th. And then if we wanted to simplify it even further, we can subtract these because they're dividing. 2 to the 7th minus 2 to the 7th, 7 minus 7 is 0, so this is 2 to the 0th power. Okay? And again, we're going to talk about those 0th powers on the next slide. I just wanted to remind you how we simplify these expressions using the rules we have already learned how to use. Let's continue on. All right, the new rule that you are learning today is that anything raised to the 0th power equals 1. And there's a lot of math proofs behind this. You can look it up and try to figure out exactly why the case is. But this is always the case, is that if anything has an exponent of 0, it equals 1. Okay, a lot of people want to say, oh, it equals 0, but that is not the truth. It equals 1. So for example, we have this expression off to the side. We're just going to multiply this because there's an invisible 1 underneath here. So 9 to the 15th times 1 is 9 to the 15th. 1 times 9 to the 15th is 9 to the 15th. And then because these are the same base and we're dividing, this is the same as saying 9 to the 0th. and 9 to the 0th, because anything to the 0th power equals 1. So this would be our final answer. So if you think back to those last three that we did on the page before this that all equaled something to the 0th power, those answers actually all equal 1. Okay? And this is what we are going to practice today. Pretty simple stuff. All right, I want you to go ahead and I want you to try these on your own. I'm going to give you 5 minutes to solve as many of them as possible. If you get to one where you're kind of stuck, just skip and move to the next one. And then we will come back together in 5 minutes and review them. If you finish before 5 minutes, just hold tight. You can work on your Moby-Max switches today, or your extra credit in Prodigy, or any missing work, or you can just sit there and stare at the wall. But in 5 minutes, we will go over this. Okay, go ahead and begin. Try to simplify each of these. All right, for this first one, we have the same base and we are dividing, so you are just going to subtract the exponents. 5 take away 2 is 3. Give me a thumbs up if you got that correct. Nice. All right, the next one, we have 4 to the 5th times 4 to the negative 8th. We are multiplying numbers with the same base, so we are going to add those exponents. We keep our base, and we add 5 plus negative 8. This is negative 3. And you don't yet know what to do with a negative exponent. You may, but we're going to learn this next week. But for right now, this is as small as I need you to make it. All right. The next one, 2 to the 8th divided by 2 to the 2nd. We are dividing, so we subtract our exponents. This becomes 2 to the 6th power. The next one, we're doing 7 times this big number to the 4th power to the 0th power. So I'm actually going to multiply everything in these parentheses to the 0th power, distribute to that first term. So we have 7 to the 0th, well that equals 1. And then we distribute this 0 to this term. Now we have 1, 2, 3, 4, 5, 6.789 to the 0th power. So this essentially becomes 7 to the 0th times this one long number, 1, 2, 3, 4, 5, 6, 7.789 or whatever to the 0th power, which just means 1 times 1, and we know that 1 times 1 is 1. Okay, it looks a lot harder than it is. It's actually really simple because we have that exponent of 0. Next one, 3 to the 3rd power again. We're raising a number that's written in exponential notation to another exponent, so we're going to multiply those 3's. 3 to the 3rd times 3 is 3 to the 9th. Next, multiplying numbers with the same base, we're going to add the exponents. 4 plus 2 is 6. And we're doing the same thing with the one beneath it. We keep our base and we add those exponents, 6, 7, 8. And then this last one right here, we're going to look at our exponents. We know we have to keep the same base because we're multiplying the same base over and over, so we keep our base of 3, but what we're trying to find here is what is our exponent. So we need to add all these up. We have negative 3 plus 4 plus 2. Well, 4 plus 2 is 6, plus negative 3 is 3. So this question mark should be a 3. It's to the 3rd power when we simplify it. So go ahead and again, make sure you've checked all your work. Let me know if you have any questions about any of the ones we just went over before we move on. All right, to simplify our work for today, our summary, and to go over all the rules we've learned so far, we're going to do this one last time with our new rule. It says when multiplying numbers written in exponential notation that have the same base, we blank the exponents. Please fill in that blank, and I'll show you an example. What do we do with those exponents? Well, we add them. Should be 3 to the 6th power. Okay. When dividing numbers written in exponential notation that have the same base, we blank the exponents. Fill in your blank. We were dividing these numbers, what will we do? Will we keep the same base? What will we do with our exponents? Well, we would subtract them. Next, when we raise a number that is already written in exponential notation to another power, we blink the exponents. So say I have 5 to the third, and I'm raising this to the fifth power. What will we do to those exponents? We keep our base. We would multiply the exponents. 3 times 5 is 15. And then the last rule that we learned today and practiced today, anything raised to the 0th power equals 1. For example, 5 to the 0th equals 1. X to the 0th equals 1. Even though we don't know what that number is for x, we know that it's going to be a 1 because anything to the 0th power equals 1. Alright, make sure you have this down. You can reference it during your exit ticket, and we're going to get into what that looks like on the next slide. Alright, here's what your exit ticket looks like today. You're going to have to divide some exponents here. Alright, you're going to have to multiply numbers written in exponential notation here. Here you're doing both, multiplying and dividing, and here you're just doing dividing. Okay, and what you're going to do is you're just going to simplify each of your answers as much as possible. I believe these are multiple choice in Galileo, so please head over there and get this exit ticket done. When you have finished your exit ticket, please do your lesson reflection and then work on your missing work until we go over it and check in with one another, okay?